Dear students, welcome to the world of triangles. Let's go to the house of right triangles. Mommy Triangle lived with her two sons, Steve and Nelson. One day, while they were sitting in their room, Steve said, "Hey Nelson, do you remember this super glue that our uncle gifted us?" "Yes, I do. It joins things quite firmly. But what are you thinking?" He was about to tell when he tripped and fell on the glue. Nelson helped him stand, but he did not see the glue on the perpendicular of Steve. When Steve thanked Nelson and hugged him, he realized that he actually got stuck to him. They tried a lot to separate but could not. Ultimately, they called their mother for help. Mommy Triangle quickly phoned the Dr. Triangle. "Miss Mommy, you have to cut the joint. There's no other way. Please tell me the length of their perpendiculars so that I can apply the medical bandage to both of them as per their length." "Sir, I only remember their angles and base length, and I don't have any measuring devices right now." "Okay, give me those data. I will calculate the length using trigonometry." Finally, the doctor cut the joint using scissors and applied bandage along the perpendiculars. Hello and welcome to Notebook. Friends, how do you think the doctor calculated the length of the perpendicular? Have you heard the term trigonometry before? No? Okay, no need to worry. Get ready to learn the exciting concepts of trigonometry. Welcome to the first and the introductory session. So students, the word trigonometry is derived from the Greek words trigonon, that means triangles, and metron, which means to measure. So basically, trigonometry refers to the study of measurement of triangles. The concept of trigonometry finds its applications in architecture and engineering. For example, to calculate the height of support towers while constructing a bridge, or to determine the correct rise and height of a stairway. In the field of aviation, trigonometry helps in calculating the distances, landing patterns, and navigation around obstacles, etc. And friends, do you know the techniques of trigonometry are also famous in the field of astronomy to calculate the distance between celestial bodies and for designing rockets? There are numerous such applications. Friends, now come out of your imagination world and consider a few situations and try to solve them. The triangles Steve and Nelson, their mom said that she knew the angles and the length of the base. But how do we know the length of other sides? Consider another situation. Suppose a circus artist is walking along a rope which is stretched from ground to a vertical pole. If the height of the pole is 10 meters and is inclined at an angle of 60 degrees to the pole, do you find length of the rope? Take another example. Suppose a bridge makes an angle 30 degrees with a river bank. If the length of the bridge is 90 meters, can you calculate the length of the river? Friends, to answer all these questions, we need to know trigonometry. To be more precise, we need to learn trigonometric ratios. Trigonometric ratios are nothing but the ratio of the sides of right angle triangle with respect to its angles. Now consider a right angle triangle PQR. Here, angle PQR, or simply angle Q, is the right angle. Let us denote the angle QPR by the Greek letter theta. Friend, what are you thinking now? Why theta? Well, this is the most commonly used Greek letter in trigonometry. You will come across many more Greek letters in this chapter. Okay, now note the position of the side QR with respect to theta. It is the side opposite to theta. It is also known as the perpendicular with respect to theta. As the angle theta lies on the side PQ, so it is said to be the side adjacent to theta. In fact, it has another name as well, that is the base with respect to theta. PR is opposite to the right angle, hence it is the hypotenuse. So friends, with respect to the angle theta, QR is the perpendicular or the opposite side and PQ is the base or the adjacent side. Now, a question is disturbing me. Does the perpendicular always represent the vertical line and base denotes the horizontal line, or do they change with respect to theta? Let's check out. For example, if angle PRQ is denoted by theta instead of angle QPR, then the side opposite to theta is PQ and the side adjacent to theta is QR. Therefore, this time PQ is the perpendicular and QR is the base with respect to theta. Friends, don't worry about the hypotenuse. It is the side opposite to the right angle. Hence, in both cases, PR is the hypotenuse. So now you will be able to identify the base and perpendicular with respect to a given angle in a triangle. I have some triangles from the triangle world. Those will surely help you. Friends, take a look at triangle ABC, right angled at B. Which side is the hypotenuse? Obviously AC, because it's opposite to the right angle. Now quickly identify the base and perpendicular with respect to angle A. Observe the side opposite to it. BC, yes, it's the perpendicular. Now spot the adjacent side. You are right, AB is the base with respect to angle A. Now let's try one more example. See, in this figure, we have two right angles, angle BCA and angle DCA. So the hypotenuse with respect to the right angle BCA is AB, and with respect to the angle DCA is AD. So can you identify the base with respect to angle CBA and the perpendicular with respect to angle CAD? Take it as your homework. This was just an introduction to trigonometry. A lot more is in our store for you. We shall be back soon with the second session to continue to talk about trigonometric ratios. Till then, revise all that we have discussed today. Team Notebook wishes you happy learning and goodbye.